Hello student, welcome to Naushala. Student, in today's session we are starting chapter 3 of your science part 1, that is chemical reaction and equation. So without wasting time, let's start. Student, in your chapter, first thing they give about the physical change and chemical change. Very simple concept there. They give few example and you have to identify which is a physical and which is a chemical change. Now first one, see, transformation of ice into water. Simple there. Here only state changing. Ice can be converted into water. Water again can be converted into ice. So reversible change there means it is a physical change. Okay. Second, cooking of food. Once you cook the food, chemical property will change. So it is a permanent change there. So it comes under chemical. Third one, see, ripening of fruit. Suppose raw mango there. In raw mango we are having acid. So it is sour in taste there. So chemical reaction happening and it becomes sweet. That is your mango there. So mango cannot be converted back into raw mango. Like that you have to understand here. Once the ripening of fruit completes, again we can't come back. Means it is also chemical change there. Fourth one, see, milk is turned into curd. So milk when converted into curd, curd again cannot be converted into milk. So it is a permanent change there. Usually permanent changes are chemical change there. Now see here, simple example they give, evaporation of water. Evaporation of water means water turns into water vapor. Now we all are knowing that if this water vapors, if you cool, if you condense it, so this water vapor again can be converted into water. So water to vapors, vapors to water. Reverse possible. So reverse possible means it is a physical change there. Okay. Next one, see, digestion of food in the stomach. Once food is digested means chemical reactions are happening in that. So you can't bring that digested food again. So it is permanent change there. So it comes under chemical. Size reduction in naphtha balls exposure to air. So naphtha ball means naphthalene white color balls are there. We are keeping in cupboards, toilets we are adding. So that naphthalene ball when kept in air, it is solid instead there. So solid naphthalene ball convert directly into the gas. That process we called as sublimation. So here also solid naphthalene ball, which chemical there? That only there when it is converted into gas. So there is no chemical change. It is just state change there. Solid to directly gas without going into liquid. That process we called as sublimation. So here they are talking about the sublimation. So sublimation is only physical state changing. So it comes under physical change. Now eighth one, see, staining of shabad or kadappa by the lemon juice. On the kitchen which tiles they are using, that is your shabad tiles are there or kadappa there. On that if lemon juice falls, lemon juice means in that acid there, right? So citric acid and this shabad tile is calcium carbonate there. So calcium carbonate and the acid in lemon juice, both reaction happening. So chemical reaction there means it is a chemical change. Okay. The last one, see, breaking of glass object. If glass falls and breaks into pieces, only solid the intact glass which was there, that is broken into pieces. Otherwise there is no change in anything chemically. So no change in chemical means it is one type of physical change there. Okay. It's very simple there. For that, for solving it is very easy. You don't take that like these questions will come in exam what? Already 3 marks question came in board. This chart only they give. And just you have to find out which is a physical and chemical. So many times like this happening, we are thinking, are so simple board will ask or what? Sometimes board will ask very simple questions. Children, you understand this. So this chart properly you complete once. Now let's move to next concept related to some activities they give on your page number 2. And they asked about what is observation about that chemical reactions. So one by one we will discuss about it. The first one, see, take a spoonful of limestone powder. Now limestone means what? Limestone means calcium carbonate there, CaCO3. This we called as a limestone. Next, read, in an evaporating dish and heat it. So you have to heat that calcium carbonate means limestone. When you heat it, always remember children, when I will teach chemical reaction, some proper thumb rules also I will give, some tricks I will give to you. so that chapter will become very easy for you. Always remember that before arrow it's CO3 there and you are heating it, or any chemical reaction you are doing. Usually what is happening, see, whenever before arrow CO3 there, then after arrow compulsory you will find that CO2 gas is forming. CO2 gas means which one? It is a carbon dioxide gas is forming whenever there is a CO3 before arrow. So here CO3 there, then that side CO2 will form. So if you remove CO2 from this, what will remain here? CaO. So this is called as a quicklime, or you can call it as a calcium oxide also. So calcium oxide or quicklime will form along with carbon dioxide. This is your first activity there. Now they give one chart to you below that, and you have to, whatever your observation there regarding this chemical reactions, that you have to fill here. Okay. So which activity they are talking about? Above activity. Color change, anything color changing or what? See here, limestone there. Limestone is white in color there. White in color. Quicklime is also white there. So this limestone and quicklime both white there. So we can say there is no change in color. Color is not changing. Second, they ask, any gas is released here? Yes, gas is released here. Which gas is released here? Carbon dioxide. So CO2 gas is released here. Okay. They asked any temperature change there? No, we are giving the heat. So like that there is no change in temperature. Okay. Now see here, last column they ask nature of change. Whether it is a chemical or physical, you can understand here. Limestone is converted into quicklime. So new substance is formed. And whenever new substance is forming with different chemical, it is considered as a chemical change. Are you getting? Here, limestone, calcium carbonate, CaCO3 converted into CaO plus CO2. So new substance with new properties are formed. Therefore, it is a chemical change there. Okay, this is your first activity. Now let's move to the second. Add zinc dust into the copper sulfate. Zinc, how you are showing? Zn is the zinc there. Where to add this zinc? We have to add the zinc into the copper sulfate. So formula of copper sulfate is CuSO4 there. This is copper sulfate. Okay. So zinc, if added to copper sulfate, what will happen? Okay, simple there, children. This zinc is more reactive there. So zinc will remove this Cu. And Cu's place Zn will take. Means ZnSO4 plus Cu will form. Okay. Now in this, children, this copper sulfate there, no, copper sulfate originally it is blue in color there. It is a blue color solution. So this copper sulfate now turned into zinc sulfate. Copper sulfate in this reaction turns to zinc sulfate form. This zinc sulfate is a colorless there. So what change you observed here? Let's talk about the chart. Activity, above activity we have to write. Color change there? Yes, color change there. That blue colored, who is there? Blue colored copper sulfate turns to colorless. This is a color change there. Blue color copper sulfate changes to colorless zinc sulfate. In this any gas is formed? No, there is no gas formation like that. Cu metal there. So here no gas formation. In this temperature changing? Yes. Here there is an increase in the temperature. Increase in temperature you will find because it is somewhat exothermic type of reaction there. Okay. Obviously new substance formed means it is a chemical change there. Okay. One more point you have to remember, children. When this copper is separated here, copper, some reddish brown colored copper get deposited in the test tube. So in color change you can write about that copper also, that reddish brown, who is that reddish brown? Copper deposited in the test tube. Okay. So two color change you can write here. Blue color copper sulfate turns to colorless zinc sulfate, and the separated copper which there, it is having a reddish brown color. So reddish brown copper deposited in the test tube. Okay. So this is all about your second activity. Now let's move to the third activity. Potassium chromate. What is formula potassium chromate? K2Cr4. Potassium chromate reacts with barium sulfate, BaSO4. Okay. Now in today's session you don't try to balance the chemical equation, because balancing is another part there. Getting all of you? So one proper video will come on channel that how to balance within a 1 minute, 1 minute also more. Less than in 1 minute you can balance your chemical equations. That my guarantee there. Okay, so you don't worry about the balancing of chemical reactions. Now just understand what activity given on your page number 2 and how to solve it. Okay, so this is your potassium chromate reacts with barium sulfate. Now what will be the combination of this? See, this part there, no, CrO4, it will bind with Ba. So your compound will form BaCrO4 plus this K2 and this SO4 will combine and form K2SO4. Okay. Now in this reaction, when this reaction will complete in test tube, children see here, this both liquid there. So this both liquid, when it will form, this barium chromate gets settled at the bottom here. This is a barium chromate there. So this is, which is solid, something settles at the bottom, to that we called as precipitate. In short, you can write PPT. So this precipitate is barium chromate there, and this barium chromate which is settled in the test tube, it is having yellow color. So they are talking about color change. So what is activity? Above activity, color change there. Yes, color change there. What is the color form? Yellow color. Yellow color, who is formed? Barium chromate is formed. So your first change will be there. Any gas is formed here? No gas. Barium chromate, potassium sulfate. So there is no gas formation. Any temperature change is observed in this reaction? Like that, there is no change in temperature. So you can write here no. Obviously, it is a chemical change there. Okay. So this is all about your third activity. Now let's move to the fourth activity. Sodium carbonate means Na2CO3 reacts with CaCl3. CaCl2, calcium chloride, CaCl2. Simple there. Here what you have to do? This both CaCO3 together, calcium carbonate will form, and 2Na, 2Cl, you can write like this, 2NaCl. Now this calcium carbonate which is formed here, this calcium carbonate, it is a white color precipitate there. Precipitate, just now how yellow color precipitate form, like that it is white in color there. So what is activity? Above activity right here. Color change, yes. White color, calcium carbonate is formed here. White color, calcium carbonate is formed here. Any gas is formed? No. There is no gas formation. Temperature changing in this? Yes. Somewhat there is an increase in temperature. So temperature somewhat increasing in this reaction, and obviously it will be the chemical change. Simple. Let's move to the next activity. This is your last final activity there. Here they are taking phthalic acid, phthalic anhydride, you have to heat. Now children here see, in this activity what they did, they took phthalic anhydride and we have to heat that. Before heating we have to take one funnel, inverted you have to keep like this and just heat it. Somewhat same experiment was there, see in 8th, that is we have to heat the iodine, and iodine crystals are settled in the mouth of this funnel. Somewhat same there. Here phthalic anhydride we have to heat it. So when you will heat it, this solid phthalic anhydride will turn into its vapor and it gets settled. It gets settled on the upper side like a white needles. So as such, here any color change there? Obviously no. There is no color change in this, because phthalic anhydride before heating also white in color there. After evaporation, that is also white in color there. Any gas is formed? No gas formation. Temperature changing? No temperature change, because we are only heating, right? So nature what there, see children, here important there. Phthalic anhydride solid there, on heating it will become gaseous. So here only state changing, property is not changing, chemical change not there, solid only gas, like camphor there, camphor also Kapoor type. So that camphor when you heat solid directly converts into gas, same there here. So phthalic anhydride when heated it becomes vapor. So here only state is changing, chemical not changing. Therefore, it is a physical change there. Okay. Now student, this all 5 activity I gave in a summarized form. Okay. So you can take one screenshot for your exam. So in this all your, how many we discussed? All 5 I gave. Okay. Now last one concept we have understand why this activity given in your textbook, so that you can understand what is the difference between physical change and chemical change. Okay. Now let's talk about. Just now we discussed so many activities. In that, new substance is formed only in chemical change. There is no new substance formed in a physical change. So your first point, no new substance formed and new substance formed in chemical. Clear? Second, if you see here, ice converts into water, water again can be converted into ice. It means physical changes are temporary there. We can reverse it, temporary. But usually chemical changes are permanent there. Once milk convert into curd, curd will be permanent. No, you can't take it back. So these are the permanent changes are there, right? When ice converts into water, see, ice formula H2O there. Ice is H2O there. When ice melts and becomes water, that is also H2O there. Are you getting? Ice also H2O there, water also H2O there. Means like this, there is no chemical composition change. Chemical composition of substance will not change. There is no change in chemical composition in physical. But in chemical composition 100% changing. If you see calcium carbonate, means limestone heated, quick lime is formed. So chemical composition changed. Getting? And the last one, physical changes are easily reversible there. Ice to water, waters to vapor, vapor to water, water to ice, anything we can do. So it is very easy to change it back. So it is usually it is reversible there. These changes mostly irreversible there. Mostly irreversible there. You can't reverse it. There are few chemical changes are there which we can reverse. Getting? But it will be difficult to that. So these changes can be reversed also, and mostly it is irreversible there. So this much you have to remember regarding difference between physical change and chemical change. Okay, so this is all about your physical and chemical change. Quickly understand what is chemical equation and word equation. See children, any chemical reaction when taking place, no, we want to present that chemical reaction, and to represent that chemical reaction, whether I am using chemical formula or I am using word, based on that equations are of two types there. One is chemical equation and second is word equation. Let's understand it. Suppose one reaction there where hydrogen react with oxygen and form water. Very simple reaction there. Now see children here. If hydrogen oxygen react and form water, this is my chemical reaction. Then that chemical reaction I can write like this. I will write the hydrogen, oxygen and then water. So here what I am doing? I am presenting that chemical reaction by writing word. Full hydrogen word I am writing. So simple representation of chemical reaction by using word is called as word equation. Now instead of word, instead of hydrogen, if I write chemical formula H2, instead of oxygen, if I am writing O2, this is also a representation there, but it is more condensed form there. Getting? So simple representation of chemical reaction in a condensed form, in a very short form, by using chemical formulae is called as chemical equation. Simple there. If your reaction represented by using word, word equation, by using chemical formula, chemical equation. Clear? Now whenever we are writing any chemical equation, first thing you have to understand that which substance taking part in the reaction, that is called reactant, and which is formed newly, that is product. Now how we will understand that reactant which there, product which there? For that some rules are there. Rules are very simple. That reactant always you have to write on left hand side and product on the right hand side. Clear? So rule number 1, first reactant always written on the left hand side and product we have to write always on the right hand side. Okay? Suppose reactant or products are more than one there. For example here, hydrogen, oxygen, two reactants are there. So these two reactants are separated by using plus sign. So my rule number 2 what there? If there are two or more reactants or products, they are separated by using separate plus sign. Now sometimes what is happening, if this arrow not there, suppose this arrow we removed. If arrow not there, then you'll get confused that from this H2O these two are formed, or from these two water is formed. So this arrow plays very important role here. Arrow tells you the direction of reaction. Means this arrow is always pointed towards the product. So if arrow is pointing towards the product, then there will be no confusion. Arrow which side there? That is new substance there. And these are the reactant there. Getting? So my third rule, reactant side and product side sides are connected by using arrow, and arrow is pointing towards the product. Understanding? So what is importance of arrow? Arrow tells you the direction of the reaction. In which direction reaction is happening, that is represented by arrow. Clear? Now rule number 4 situation. Rule number 4 is very simple there. If I am having any chemical reaction, and in that reaction we have to heat that reaction, because when temperature increases, then some reactions are taking place. So in any chemical reaction, if outside heat is provided, if you are heating that chemical, so heat is provided, then we have to mention that we give heat. Getting? So that if heat is supplied to any chemical reaction, for example here calcium carbonate, limestone there, limestone. So in limestone, if you heat, then only it will convert into quicklime and CO2. So that heat is given is represented by symbol triangle, and this triangle you have to write on arrow. So whenever you find triangle there on arrow, means you have to understand that in this reaction heat is given from outside, heat is supplied. Clear? Now rule number 5 is very simple there. Some reaction on just by heating will not complete. Some extra conditions we have to give that. Means high temperature is important only there. Sometimes some reaction occurs at high pressure. Some reaction needs some extra catalyst. Catalysts are special chemicals are there. If that catalyst present, your chemical reaction will be faster. If something like this there, temperature special there, pressure there, catalyst there, these all special condition we have to mention on arrow like this. You write you present the arrow, above or below that arrow we have to mention all these reaction condition. That is your rule number 5 there. Rule number 6 what there children, if you want to make the equation more informative, your chemical equation should tell more information. Whoever reading that reaction, a chemical equation, then if you write like this, for example here I wrote CaCO3, in bracket I wrote S. So in bracket S there means what? S for solid, means calcium carbonate solid there. This side see, product side also we wrote here S, means CaO also solid there. CO2 in bracket we wrote G, small g means CO2 is a gas there. Means to make the chemical equation more informative, we are writing their physical state in small bracket. Getting? So my rule number 6 what then? Physical state of reactant and products are written like this: G for gases, L for liquid, S for solid, AQ for aqueous solution. Means if something dissolved in water, then that dissolved in water that we represented by AQ. AQ means aqueous, aqua means water. Okay, this is rule number 6 there. Now children, rule number 7 what there? It is an alternate there. Means if any chemical gives gas, then this gas H2 is a gas there. So I can write in bracket small g like this also. Suppose you don't want to write G in the bracket, means gas, if you don't want to represent in this way, there's one more way there to represent that. What you have to do? You have to show one arrow pointing upward. If any reaction you find like this, if you observe here hydrogen upward arrow is shown. If like this arrow, upward arrow shown, means in this reaction gas is produced. Getting? So there are two ways there. Instead of writing small g, you can give upward headed arrow. Simple. Now some reactions are there. Some reactions are there in which, suppose for example, see here, AgNO3, NaCl. Both liquid chemicals are there. AgNO3 liquid you take, NaCl means salt solution you take, and both you mix. When you mix, then AgCl, silver chloride, will form. But this silver chloride is forming in the form of solid. Try to understand this. Suppose I am doing this chemical equation in a test tube. So both liquid, when you mix, one chemical will be settled at the bottom, product. One product after reaction settle at the bottom. This settled bottom product which there, that we called as a precipitate. Precipitate means one chemical will be settled at the bottom of test tube in the form of solid. That solid we called as precipitate. Now when we write chemical equation, then how we will identify that one product is solid there, it is settled at the bottom of test tube? For that, simple what we are doing, we are showing one downward headed arrow. Downward arrow. We have to show that. So if the product is insoluble solid means precipitate is formed, it is shown by downward arrow instead of S. Means solid we can show, but just now how we did, instead of writing gas as a G, we shown upward arrow. Here you have to show just downward arrow. Clear? Now one more we are having, last one. Suppose in the reaction heat is released there. Now don't confuse here. Earlier one which we discussed just now, here we were giving the heat. Suppose to occur that reaction, we are giving the heat, then that heat is represented by using triangle, and triangle we are writing on arrow. Now which I am talking, children, here we are not giving heat. When these two chemical will react, some heat is released out. In the reaction, heat is released means it is exothermic reaction there. Exothermic means heat is released in the reaction. If any reaction gives out heat, then that heat we have to write after the plus. Means product side when you are writing heat, it means heat is generated, heat is released during the reaction. So my last, ninth one, if the heat is released during reaction, that heat is written on the product side like this. Okay. So now one small, after this rule, one small activity is given to you in your textbook. Let's understand what is exactly activity there. They are telling you, take a sodium chloride solution in a conical flask. Okay. So we took here sodium chloride solution. Now they are telling silver nitrate solution. So let's take silver nitrate solution in test tube. And they are telling tie a thread to this test tube. Means here you have to tie the thread and insert carefully like this. Means in this conical flask, silver nitrate solution take in test tube and release in that. You have to put this test tube into this. So it will look like this. Your outside beaker is having sodium chloride and in test tube there is a silver nitrate. Now they are telling tilt this. So if you tilt this, these both chemical get mixed. This both chemical get mixed and reaction will take place. What is that reaction? See, silver nitrate when react with NaCl, silver nitrate when react with NaCl, it will form AgCl and NaNO3. Means silver chloride and sodium nitrate will form. Now this AgCl is a precipitate there. Precipitate means what? Solid thing which is settled at the bottom. Okay. So observation what there? Some insoluble white precipitate of sodium chloride is formed. That only. In a chemical reaction, sometimes just now we discussed here. Solid sometimes reaction when complete, solid will settle at the bottom. That solid we called as a precipitate. So here who is precipitate? AgCl will form. So white color AgCl will settle at the bottom here. If you see a somewhat white, you will find this white which is looking, it is nothing but AgCl white precipitate there. Okay, this is a half part of the activity. Somewhat extended one question they asked to you. If we are doing this reaction, before tilting, means before the sodium chloride and silver nitrate, before they react, take their weight. So suppose their weight is coming 125.50 gram. Now do the reaction. Both react. After reaction, once again take their weight. So here you will find that before reaction their mass is 125.50. After reaction also it is 125.50 gram. Means what it is? Mass of the reactant before the reaction and mass of the product after the reactions, both are equal. This is called law of conservation of mass or law of conservation of matter, you can call it. It means that total mass of the reactant is always equals to total mass of the product. That just they want to represent to you. Okay, so this all about your chemical equation and rules to write the chemical equation. Student, whenever you are balancing any chemical equation, you have to follow one particular sequence. Then you will feel that chemical balancing very easy. That whenever equation comes front of you, first identify which is metal, non-metal, oxygen and hydrogen in that. And your balancing sequence, you keep always first balance metal, then non-metal, oxygen and hydrogen. No doubt, oxygen, hydrogen also non-metal only there. But the sequence of balancing you have to keep in that way, that first you will balance the metal, then non-metal, then oxygen, then hydrogen. Getting? If you go by this step, 100% your equation get balanced very easily. Let's try this. Now here we are having first equation. Now children, we are understanding the first method. Therefore, little bit slowly I will explain the first one. The next onwards you can do within a 30 seconds. Okay? Now focus here. Now here see children. Here in this equation, which is a metal you have to find out. Na is a metal there. Can you see here? Metal Na there. So I will balance first Na. Sodium Na2 there here. Here 1 there. So multiply by 2. Okay. So Na2 here. Here also 2 there. Now second you have to find out non-metal other than oxygen, hydrogen. So other than oxygen, hydrogen we are having sulfur, non-metal there. So sulfur here 1 there. Here 1 there. So it is already balanced there. So this two step over, now come for oxygen. Here oxygen, see children. Actually 1 there, but you multiply by 2 here. So 2 multiply, therefore here oxygen becomes 2 and here 4, total 6 on this side. 4 here there, here 1 there. So multiply by 2. So 2 and this 4, total 6 will happen. Okay. Now go for hydrogen. Hydrogen, see children, here multiply by 2 there means here 2 hydrogen. Here 2 hydrogen, total 4, 2 2s are 4, means your equation get balanced. That's it. So simple there. In this sequence you just go metal, non-metal, oxygen and hydrogen. Getting? Simple there. Now let's do the next one. Now children, here equation given to you H2S2O7 H2O H2SO4. Now first thing what to do? Find out the metal. In this any metal there? No. Metal not there. Then find out the non-metal. Non-metal who is there? Sulfur there. How many sulfur here? 2. Here sulfur 1. So multiply by 2. Perfect. Then go for oxygen. Oxygen count 7 here, 1 here. Total 8 are there. 4 2s are 8. Balance. Go for hydrogen. Hydrogen here 2, 4 there. 2 2s are 4. That's it. Equation get balanced. That only I am telling within 30 seconds. 30 seconds also will be more for you. Check once again. Now go for this one. Ag is a metal there. Ag is a metal there. So Ag here 1 balance. Non-metal chlorine there. Here also 1 chlorine there. Balance. Oxygen not there. Go for hydrogen. Hydrogen here 2 there. Here 1 there. So multiply by 2. Okay. Now this sequence over, then go once again back to metal. Metal here 1, here 1. Okay. Non-metal here now 2 Cl happen. 2 Cl. So multiply by 2. 2 Cl completed. Hydrogen 2. Hydrogen 2. Now go back again. Metal Ag 1 time. Ag 2 time. So multiply by 2 here. 2 Ag, 2 Ag, 2H, 2H, 2 Cl, 2 Cl. Equation balance. Go. Now let's see next. Now here is Mg plus O2 MgO. Simple there. Magnesium metal there. Magnesium metal there. 1 1. Non-metal not there. Oxygen there. 2 here. 1 here. So multiply by 2. Oxygen balance. Hydrogen not there. Go back again to metal. Metal now here 2 mg there, here 1 there. So multiply by 2, equation balance. Now check this children. Here metal not there. Non-metal there, yes. Sulfur is a non-metal there in this. So sulfur 1 here, 1 here. Total 2. So multiply by 2. Okay. Now go for oxygen. Oxygen 2 here, here 1 only there. So multiply by 2. Oxygen completed. Hydrogen check now. 2 hydrogen here, here 2 2s are 4 there. So multiply by 2 here. Okay. So one round completed. Go back again to metal. Metal not there. Non-metal check now. Sulfur 1 here, here 2 happen now. Total 3. So make it 3. Perfect. Go for oxygen. 2 here, 2 here. Perfect. Hydrogen C. 2 2s are 4, 2 2s are 4. Equation balance. That's it. Now go for next one. Now here say children, potassium is a metal there. So first we will balance the metal. K one time, okay. Second non-metal, chlorine there. So here 1 there, here 1 there, balance. Go for oxygen. 3 there, 2 there. So make it 3. You can't make 3. So just one number increase. So make it 4. Okay, multiply by 2. Hydrogen not there. Go back to metal again. Okay. Metal still 1 1 there. Chlorine 1 1 there. Oxygen check now. Here 2 2s are 4. Here 3 only oxygen there. So let's multiply by 2 to increase the number. Okay. Now oxygen completed. Hydrogen not there. Come back again to metal. Metal now 2 there. So multiply by 2. Perfect. Cl2 happen. Cl2 there. 2 3s are 6. Here you make 2 3s are 6. 3 2s are 6. Equation balance. So in this way you go. Metal, non-metal, oxygen, hydrogen. If suppose not balance, again start with metal. But keep sequence same. Within a 30 second your equation get balanced. Now sometimes some reactions are like this. There no, this sequence you have to repeat many times. Means once you go metal, non-metal, oxygen, hydrogen, again and again you have to come. Then you will get the balance equation. So don't worry, you have to follow the same rule. Check here. Metal, aluminum there 1 time. Okay. Non-metal, chlorine there, here 1 there, here 3 there. So multiply by 3. Okay. Oxygen not there, hydrogen check. Hydrogen here 2 there, here 3 there. So here you have to make the multiple of 3. So 3 2 the 6 will happen. Okay. Now come back to again metal. Aluminum 1, non-metal C, Cl3, Cl3. Hydrogen check. 3 2 the 6 there. So 3 2 the 6 means here you have to make the 6 hydrogen. Ready? So 6, 3 2 the 6, balance. Again come back to metal. Aluminum 1 time, non-metal C, 6 happen now. 3 2 the 6 will happen here. Okay. Hydrogen 6, here also 3 2 the 6. Come back again to metal. Metal here 2 time there, here 2 time there. Now your equation get balanced. So if answer not coming, then repeat the process. Finally 100% you will get the answer. Okay. So this is all about how to balance the chemical equation quickly within a 30 second. Understand the first type of reaction. I gave 3 examples to you. If you see the first one, here ammonia hydrogen chloride when react, it will form ammonium chloride. Now whichever chemicals are written on the left hand side, these chemicals we called as a reactant. And the right hand side which we are writing, these are the product there. Now see children here. Ammonia hydrogen chloride means total how many reactants we are having? 2. But if you see product side, only ammonium chloride is formed, means there is a formation of only one. Means single product is formed in the first reaction. Reactants are 2, product is 1. Okay. Now see the second one. Here also magnesium oxygen means 2 reactants are there. And magnesium and oxygen when react, it will form magnesium oxide. Here again you will find only one product, single product is formed. See the third reaction. Calcium oxide and water when react. Here also number of reactants are 2 there. And product is only one, that is calcium hydroxide. Single product is formed in the third reaction. Now if you compare these 3 reactions, what conclusion you can find? Simple conclusion there. In all 3 reactions, product is one only there. See, ammonium chloride, magnesium oxide, calcium hydroxide. So in all these reactions, there is a formation of single product. when two or more reactants are combining, there is a formation of single product, then such type of reactions we called as a combination reaction. So what is combination reaction? When two or more substances react and form a single product. So my first type of reaction is a combination reaction. So what to write in paper? When two or more reactants combine and form single product. Such type of reaction is called as combination reaction, and out of these three, any one example you have to give for combination. Okay, simple type there. Now, one more type of reaction there which is exactly opposite to your combination. Okay, now see this. Here, sugar there. Sugar means sucrose, there it is, C12H22O11. Sucrose means sugar which we add in tea. Its formula there. Now this sugar, if you heat it, if you are heating it, then it will turn into carbon and water. Now see here, LHS side reactant there. So sugar is only one reactant we are taking here, and this only one reactant after heating broken down into two products. So number of products are two, one carbon and second water. Okay. Now check the second reaction. Calcium carbonate means it is a limestone there, limestone. How many chemicals are there here? Only one. So in second reaction also we are taking only one reactant and you are heating it. When you heat calcium carbonate, it will break into calcium oxide and CO2. So number of products are two here, but reactant calcium carbonate was only one. Now check third one. H2O2 is hydrogen peroxide there. So here also single reactant there. Reactant single. Product C, water plus oxygen. Means two products are formed. Are you getting? Something's last type of reaction in that how you remove conclusion. Try to remove conclusion of this. Here also if you find in all these reaction, reactant one only there. Single reactant there, and from single reactant there is a formation of two or more products are there. So the type of reaction in which two or more products are formed from single reactant, such type of reaction we called as decomposition reaction. What is decomposition reaction? When two or more products are formed from single reactant. So my second type of reaction is decomposition reaction. So how to write in paper? The chemical reaction in which two or more products are formed. See here, two products are formed from single reactant. Here also single reactant, here also single reactant. Easy? So how I will define the decomposition reaction? The chemical reaction in which two or more products are formed from single reactant. Such type of reaction we called as a decomposition reaction. Okay? Now let us understand the difference between combination and decomposition reaction. In combination reaction, what we are telling? Two or more reactant combines and form single product. So when two or more reactant combines and form single product, combination there. Decomposition, what there? Where two or more products are formed from single reactant. So here single reactant breaks into two or more product. That is your decomposition there. How we can represent in general formula? A plus B, two reactant, AB, single product. In decomposition, single reactant AB breaks into two product, A plus B. That is a general way to represent combination and decomposition. In combination, how many products are formed? Only one product there, one. If you see in decomposition, there are two or more than two products are formed in case of decomposition. Generally in combination reaction, energy is released. Means these reaction mostly comes under category exothermic. Means heat is given out, released, or you can call it heat is evolved. Here in generally decomposition reaction, if you check the last slide, here we gave the heat. Before one slide, see here. Here we are giving the heat. Here also we are giving the heat. Means in decomposition reaction, heat we are supplying. So usually it requires the energy from outside. Means these are generally endothermic reactions are there. Heat is absorbed in the reaction. That is endothermic there. Okay, so it is generally exothermic, heat is given out. It is endothermic, heat is required to do this reaction. Okay, and any one example you can give under the combination and decomposition. Clear? So this is all about the combination and decomposition. Now understand one important reaction, that is displacement reaction. Now student, here example C. We are having copper sulfate, CuSO4. CuSO4 is a compound there which is a blue in color there. When this compound I am adding in water, that CuSO4 undergoes dissociation, means it gets separate into its ion. What are the ion? Cu2 plus, SO4 2 minus. In this ion it's separated. In that solution, if you add Fe, iron, if you add, this iron is a more reactive element there. And whenever you add more reactive element in a copper sulfate, what is happening? See, as Fe is more reactive than this Cu is a less reactive there. So when you add Fe in this Fe will take the place of Cu. So if you see the product side, instead of Cu, Fe is there with SO4 now. First it was CuSO4. Now in product you will find FeSO4. Why like this? Because less reactive elements. Who is there less reactive? Copper. Its place is taken by Fe. So in such reactions we called as a displacement reaction. Why? Place is taken by more reactive element. Whose place? Less reactive elements. Get it? So the reaction in which the place of less reactive element, is taken by another more reactive element. That is displacement there. Are you getting? But when Fe wants to take the place of Cu, only Fe can't take that. Fe should first convert into Fe2 plus, 2 plus. Then this 2 plus can take this place. Understand? Fe can't. Fe ions can take the place. So whenever the place of less reactive element is taken by another more reactive element, it should form its own ion. Fe can't. Fe2 plus possible. So first Fe will form its own ion and then it will take the place of Cu. Getting? So in this way, if you understand the definition, now you read, you'll get what is meaning of the definition. The reaction in which the place of less reactive element in a compound, who is less reactive element? Copper, is taken by another reactive element, more reactive element. How? By formation of its own ion. Means Fe can take the place, but first Fe should become Fe2 plus to take that place. So such type of reaction we called as a displacement reaction. Definition little bit lengthy there. You can repeat with me. The chemical reaction in which the place of less reactive element in a compound is taken by another more reactive element. How? By formation of its own ion is called as displacement reaction. Okay. Now few examples here. It is in your textbook only it is asked. If CuSO4 Fe reacts, what is formed? Just now we wrote this. FeSO4 plus Cu gets separated. Okay. CuSO4 means copper sulfate and lead. Now see, lead also more reactive there. Lead also more reactive than copper. So lead will take the place of Cu. So what will form here? PbSO4, lead sulfate, and here also copper again get separated. Such type of simple reaction can be example of displacement. Now let's understand the next type of reaction, that is double displacement reaction. To understand double displacement reaction, in your textbook one question they asked under use your brain power. This is the question given in your textbook. They asked the potassium chromate when added to solution of barium sulfate. Now potassium chromate, what is K2Cr4 reacting with barium sulfate, that is BaSO4. Whenever children you are solving the double displacement reaction, always remember one thing. Divide this compound into 4 parts. This first metal as a 1, its partner will be second. Next metal will be third and its partner will be fourth. In this type of reaction, one simple method I will tell you what to form, what to make the product by using these two. Always you remember that here combination will be 1 with 4, 3 with 2. 1 4 3 2. One position ion will combine with fourth and third will combine with second. Okay. Now use that rule and tell me. First combine with 4 means K2 SO4 will form 1 4 and 3 2. 3 2 means what? Barium and chromate. So compound will form BaCrO4. Now this barium chromate is a solid precipitate there here. Solid. If you check the previous videos of this topic on same channel, you will understand what is meaning of precipitate. When two liquid combine, after reaction one product will be solid. This solid thing which formed, it is called as a precipitate. So barium chromate is a precipitate here. Okay. So this is your balanced equation there. Okay. Understood how to balance? 1 with 4, third with 2. Simple. Now write the name of precipitate. Who is precipitate? Solid what there? Barium chromate. So barium chromate will be the name. Now many children write here formula, means BaCrO4 they are writing. Carefully you have to read. They ask the name, not the chemical formula. Chemical formula ask, then you can write BaCrO4. But they are asking name, so name write. What is the color of this? Remember the color of barium chromate? Yellow color precipitate is forming. Okay, simple. Now, what exactly happened in this reaction, see children? Here, one ion, this ion combined with this side, and CrO4 combined with Bn. Means you can simplify in this way. Suppose I am writing AB reacts with CD. AB reacts with CD. So after reaction, what you find? A is going with whom? A is going with D. AD will form, and this both will combine. CB will form. So it's just an exchange of ion there. Partners are changing. So in reaction in which there is an exchange of ions, and that result in formation of something solid precipitate. So important there here two things. One, precipitate should form and ions should be exchanged like this. Ion exchange means, understood everyone? This will go with this will come with this. It is called exchange of ion. So the reaction in which there is a exchange of ions. When ions are exchanged and precipitate is formed, such type of reaction we called as a double displacement reaction. Very simple definition there. Reaction in which the ions of the reactants are exchanged. Ions of the reactants are exchanged to form a precipitate. Such type of reaction we called double displacement reaction. Getting? Now let's compare both. Displacement and double displacement, what is difference? In this what we understood? In this we understood that less reactive element which there, that place is taken by more reactive element. So definition easy there. The reaction in which the place of less reactive element is taken by another more reactive element by forming its own ion is called displacement reaction. Double displacement, just now we have understood, reaction in which ions are exchanged from the reactant to form a precipitate is called double displacement reaction. Both side definition. Now in displacement reaction, color change possible, but there is no precipitate formation. Precipitate is not formed in this. If precipitate form, 100% it is double displacement there. So my second point, no precipitate formation, precipitate formation. Okay. Third one, generally here what we are doing, see one metal there. For example, Fe was there, Fe. So otherwise take example of zinc. Zinc there, zinc replaces the Cu. So metal react with salt solution. Copper sulfate is a salt solution there. Zn is a metal there. So in this reaction, metal react with salt solution. Here come. Here Na2SO4, BaCl2. Both are the salt solution there. Means in previous slide if you see here, K2CrO4, BaSO4. These both are the salt solution there. So both salt solution will react and one precipitate is forming here. So that only given here, salt solution of two different metal react with each other to form a precipitate. Okay. So definition, both side definition you write. precipitate is not formed, precipitate is formed. Here one metal react with salt solution, and here two salt solution of metal will react and precipitate is formed. And one more example just to write. So that will be your difference between displacement and double displacement. Okay, completed combination, decomposition, displacement and double displacement type of reaction. Now students, suppose we are having first chemical, that is coal there. Coal means actually it is carbon there. So when you burn the coal in presence of air, air means in presence of oxygen. So when we burn the coal in presence of oxygen, means carbon is actually reacting with oxygen. And what is the product form? Carbon dioxide. So C plus O2 gives CO2. Very simple reaction there, nothing special in this. Special what there? When this reaction is happening, there is a release of lot of heat outside. Heat is released. Means there are some reaction in which heat is given out. So such type of reactions we called as exothermic reactions. Exo means exit, release. Therma means heat. So exothermic means release of heat. So the reaction in which heat is given out, such type of reactions we called as exothermic reaction. Not only this children, if suppose I am doing this reaction in test tube, same reaction there. Suppose A is reacting with B to form AB. Very simple reaction there. But here problem what there, when A reacts with B, during their reaction, the heat is given out. Heat is given outside. Now where that heat will go? Heat will go in the surrounding solution, this blue color. So during chemical reaction, exothermic reaction, when heat is given out, the temperature of the surrounding solution will increase. So 2 points you have to remember here. One, the chemical reaction in which heat is given out is called exothermic reaction, and whenever exothermic reaction is happening, the temperature of the surrounding solution is going to increase. Clear? Now see children, here I am having here one limestone piece there. Limestone, which we called as a calcium carbonate, means CaCO3 there. Now this calcium carbonate limestone, if I heat by using gas burner, so when you heat the calcium carbonate limestone, it will turn into a powder of quicklime, which is called as calcium oxide, and there is a release of one gas during this, that is carbon dioxide. It is a one type of decomposition reaction there. Already previous sessions we completed few type of reactions. In that, this reaction came already in a decomposition, means single reactant broken down into two or more product. Getting that type of reaction there here. So here concept what there, when calcium carbonate limestone you are heating it, then it will break into two product. But for this reaction to take place, we are giving the heat. Means this calcium carbonate, when we heat, it will take the heat from outside and then it will change into two product. Suppose we are not giving heat only, then this reaction will not happen. Means to complete this reaction, that limestone, means calcium carbonate, should absorb the heat. If it absorbs the heat, if it takes the heat from outside, then only this reaction will take place. Means there are some reaction where reactant should take the heat from outside. It should absorb to complete that reaction. That type of reaction there here. Calcium carbonate means limestone, till it is not absorbing the heat, reaction is not going to take place. Getting? So such reactions we called as a endothermic reaction. Endo means inside. Heat means thermic. So heat should come inside the reactant. So the chemical reaction in which heat is absorbed is called as endothermic reaction. Getting? Means to complete this reaction, heat should be absorbed by the reactant. Now imagine that same reaction if I am doing in test tube then. Again I am having A is there, A there, B there, completes and form suppose AB, like this something chemical there. Now to complete this reaction, if it is endothermic there, when this AB will react, it will take the heat from outside. These reactant will take the heat from outside. If they take the heat from outside, if they absorb the heat from outside, then only product will form. Means this A reactant, B reactant, when it is reacting, it will take the heat from outside. Now outside who is there? Outside this blue color solution there. This blue color solution there. Means when A and B will react, it will take the heat from solution. Now 2 minutes, imagine. If the solution's heat is taken by these two, then solution's heat will decrease because that heat is taken by these two. So solution's heat if going to reactant, then ultimately the temperature of the solution will decrease because all the temperature, all the heat of solution is absorbed by these two. Getting? So whenever endothermic reactions are happening, the temperature of the solution will decrease. Why it will decrease? Because the solution's all heat is absorbed by AB during the reaction. So 2 important points. 1. The reaction in which heat is given out, heat is released, such type of reactions we called as exothermic reaction. And during exothermic reaction, temperature of the solution always decreases. Okay? Now see children here. If I compare exothermic, endothermic as a difference between, what point we should write here? First, definition simple there. The chemical reaction in which heat is evolved, means released, is called exothermic. Endothermic, what there? The chemical reaction in which heat is absorbed, that is called as endothermic reaction. Just now what I explained to you, during exothermic, heat is evolved, evolution of heat there. Then the temperature of that solution will increase. The test tube containing solution, its temperature increases because heat is given out. Opposite here, in this reaction, heat is absorbed from the solution, so the temperature of the solution will decrease. Clear? Third, generally exothermic reactions are little bit fast happening. You see, anything you burn, suppose Diwali crackers are there, when it is burning, heat is given out there. Diwali crackers there, when you burst it, so quickly it is happening. It's not that today you will light up it, tomorrow you come and say, oh, blast happened. Like this, not there. Sudden there it is. So it is fast there. These reactions are little bit slow there because it is taking heat from outside. So to take the heat inside the reaction and to complete it, it takes time. So little bit these reactions are slow there. Example, anything you can write. NaOH when you add in water, it will release the heat. And just now limestone, calcium carbonate, when you heat it, it will turn into quick lime and CO2. That example you can mention in case of endothermic reaction. So overall, what you will remember the difference between, in this heat is released, in this heat is absorbed, temperature of the solution increases, temperature of the solution decreases, fast reaction there, slow reaction there, example. Okay, so this is all about your exothermic and endothermic reaction. Now in your exercise, few examples they give and they told to you, find out which reaction is exothermic there and endothermic. It's very simple there. One simple method I will tell you how to identify the reactions here. Whenever they will give the equation, first you focus on heat. 2 words you have to search. Heat word or its symbol triangle you have to see in the reaction. Okay. Now see this first reaction, see. HCl NaOH gives NaCl plus H2 plus heat. We are not interested in other. We are interested only 2. Heat where there, triangle where there. Now if the heat word is coming after arrow, means product side, means it is heat is given out. Heat is given out means it is which type of reaction? Obviously it is exothermic reaction there. Simple there. How will you find out? Just see the heat or triangle where it came. After arrow if it comes, means it is exothermic reaction. Now see here. 2 KClO3 gives 2 KCl plus 3O2. In this triangle came here, triangle on the arrow there. On the arrow means it is reactant side you have to catch. So before arrow or on the arrow, if heat or triangle symbol is coming, means it is an endothermic reaction there. So you compulsory these 2 things you have to remember, that if heat or triangle comes this side, product side, exothermic, on arrow or before coming, endothermic. Simple. Now come here. CaO plus H2O gives CaOH twice plus heat. Heat word came after arrow, so obviously it will be exothermic reaction. Okay, now here see CaCO3 triangle came on arrow. So on arrow or before it will be endothermic. So what there here? So simple thing there. Where heat word coming, that just you check. You can find out this. Okay. Now let's move to one important concept of oxidation reduction. Now students see here. Here copper reacts with oxygen. So copper reactant there. Reactant there here. Copper is reactant there. To that reactant, oxygen reacting and forming CuO. It means what happened here? Oxygen added to copper. Means copper takes the oxygen and becomes copper oxide. Right there? Now see here. Magnesium hydride there, MgH2. MgH2, after the reaction, Mg gets separated, hydrogen separated. So if I compare these two reactions, in first reaction what happened? In first reaction, reactant gains oxygen. Oxygen gain happened. Means first copper was not having oxygen. Now after reaction, oxygen there. So copper here gains oxygen. Now second see, magnesium, first magnesium was having hydrogen. Now magnesium alone there, hydrogen not there. Means magnesium here loses hydrogen, loss of hydrogen happening. Right there? Any confusion in this? In this reaction, copper was single, copper gains oxygen, becomes copper oxide. Magnesium hydride, magnesium with hydrogen. Now after reaction, magnesium separate there, hydrogen loss happen. So it's such type of reaction in which reactants gains oxygen, like this gains oxygen or loses hydrogen. Such type of reactions in chemistry we called it as a oxidation reaction. Oxidation. From name only you can find out. Oxy means oxygen. Dation, addition. So in copper, oxygen's addition happen. In this, oxygen addition happening. Therefore, it is oxidation reaction there. Okay, here two conditions are there. In both way, it is oxidation. If gain of oxygen there or loss of hydrogen there, both in chemistry we called as a oxidation reaction. Okay, now 2 minutes here. See, suppose I want to define the oxidation reaction. Then what I will write? Simple. From here to here, for every reaction we are writing the chemical reaction in which starting same only there. What to write? Just reactant. What doing here? Reacting, either it will combine with oxygen. Here combine with oxygen, or there's loses of hydrogen. See here, loss of hydrogen happen. Magnesium loses hydrogen. Such type of reaction we called as oxidation reaction. Okay. Suppose in exam they ask explain oxidation reaction. Then one definition, one example you have to explain. Okay. Definition simple there. Chemical reaction in which reactant gains oxygen or loses hydrogen is called oxidation reaction. Simple. Now see here. Now this reaction, see, it is very interesting. See there, mercuric oxide there, HgO. After reaction, if you see Hg alone there, whose loss happen now? Oxygen. So it is a loss of oxygen there. Here see, hydrogen reacts with chlorine gas and form HCl. Now hydrogen was alone, chlorine was alone. This hydrogen is added to chlorine to form HCl. So here it is a gain of hydrogen there. Gain of hydrogen. So if you compare the previous one, in oxidation what happened? Gain of oxygen, loss of hydrogen. Here opposite there. Here loss of oxygen, gain of hydrogen there. Getting? So such type of reactions we called as a reduction reaction. Reduction. In reduction what is happening? Reactant will lose the oxygen or it will gain the hydrogen. Here gain of hydrogen there. Hydrogen is added and here loss of oxygen there. Now if you want to write the definition same way you write chemical reaction in which same there. In previous what we wrote, reactant gains oxygen. Here you have to write hydrogen. So reactant gains hydrogen, loses oxygen is called as reduction reaction. Okay. Now student, let's move to one important concept of oxidation. Full focus on board, dear children. Now here Fe is one type of atom there. This Fe atom when loses electron, how many electron lost? 2 electrons are lost. Then Fe becomes Fe2 plus ion. Means positive charge increased. Here nothing there, here 2 positive happen. Okay, now come here. If this Fe2 plus ion one time again loses 1 electron, then this Fe2 plus becomes Fe3 plus. Means what is the concept here? Fe no charge, 2 positive, 3 positive, means there is an increase in positive charge. If any time there is an increase in positive charge in chemistry, to this we called as a oxidation. So it is also one type of oxidation, increase in positive charge. Now see here, here I am having sulfur ion there, sulfur ion having -2 charge. So if 2 minus charge sulfur ion, if loses 2 electron, loss of electron happening, 2 electron lost, then that 2 minus charge will go, no charge, 0 charge will come here. So what happened here? 2 minus becomes 0, means there is a decrease in negative charge, and decrease in negative charge also in chemistry we called as a oxidation. If positive charge increases, oxidation, negative charge decreases, that is also oxidation. And in both cases what is happening? Here also loss of electron there, here also loss of electron there, means loss of electron is important there for oxidation. So loss of electron is actually oxidation there. Oxidation means loss of electron. Okay, you can remember by using this trick, oil, OIL. Oxidation is loss. Loss of what? Loss of electron only. No, vada pav will be not there. So oil means what? Oxidation is loss there. Simple. Now see here. Now here I am having sulfur atom, not ion. I am having sulfur atom, no charge. If this sulfur atom takes 2 electron from someone, taking electron. So if electron is taken, gain of electron happening, then negative charge will come. So 2 electrons are taken, 2 electron gain there, therefore 2 minus. Suppose this ion again taking 2 electron from someone, then this 2 minus becomes 4 minus. So what is happening here? There is an increase in negative charge, and increase in negative charge in chemistry we called it as a reduction. If any time there is an increase in negative charge, it will be considered as a reduction. Okay. Now if you take the Fe ions example, if this Fe3 plus taking 1 electron, electron is taken, gain happening, then this 1 minus and this 1 plus will cancel, then 2 plus will remain. So here 3 plus there, here 2 plus happen, means positive charge what happened? Decreased. 3 plus when becomes 2 plus, it will become decrease in positive charge, and this decrease in positive charge also we called as a reduction. Simple. Here no charge, 2 minus, 4 minus, increase in negative, reduction. 3 plus becomes 2 plus, means decrease in positive, that is also reduction there. But what is common in both? See, what is common in both? In this also gain of electron there, here also gain of electron there, means here important there gain of electron, and that gain of electron is actually reduction there. Gain of electron is actually reduction there. So loss of electron oxidation, gain of electron reduction. You can remember like this, RIG, R-I-G, reduction is a gain. And there what, which word I give? Oil, O-I-L, oxidation is loss. Okay. Now let's compare both oxidation reduction in the form of difference between. Very simple there. Already you are knowing that oxidation, what is there? Addition of oxygen or loss of hydrogen. Exactly opposite that side. Okay. Here just now I gave one word to you, oil. Oxidation is loss. So loss of electron, oxidation. Here I gave one word, RIG, reduction is gain. So gain of electron, reduction there. And in detail just now I explained to you, if positive charge increases or negative charge decreases, it is oxidation there. Exactly opposite that side. And one example you write. Okay, so now let's understand the first factor by using one simple activity. Children, what you have to do here, take two metal, aluminum and zinc, and add dilute hydrochloric acid into it. So aluminum also react with HCl, zinc also react with HCl. and in both case hydrogen gas will form. You have to observe that what difference you find in that. So let's do the first activity. In aluminum we will add the hydrochloric acid. So when this both will react, hydrogen gas will form. Same way when you add dilute HCl into the zinc, here also reaction will take place. Here also hydrogen gas will form. But hydrogen gas bubble formed in case of aluminum, you will see large number there. More number of hydrogen bubbles you can see in this case. Compared to this, in zinc also hydrogen bubbles are formed, but these hydrogen bubbles are very low there. Less number of hydrogen bubbles you can see in zinc. What it means that more hydrogen bubble means reaction here faster there, and less hydrogen bubbles are seen means reaction here slow there. So slow reaction, less hydrogen bubble, fast reaction, more hydrogen bubble. So in which metal we got more hydrogen bubbles? More hydrogen bubbles we are getting in case of aluminum. It means that nature of the reactant is very important there. If the reactant is more reactive, then reaction will be faster. Getting? So my first factor affecting rate of reaction is nature of the reactant. If more reactive substance there, reaction will occur faster. Getting? In this case, who was more reactive? Aluminum. So aluminum will do faster reaction compared to zinc. Zinc is less reactive, slow reaction doing. So aluminum is more reactive there than the zinc. Therefore reaction is faster in case of aluminum. So what we understood that nature means reactivity. So nature means reactivity of the reactant affect rate of chemical reaction. Affect means what? If reactivity more, faster the reaction. If reactivity less, slower is the reaction. That is my first factor affecting rate of chemical reaction is nature of the reactant. Now let's move to the second one. Now to understand the second factor, let's do one more activity. Here what we are doing, Shabat tiles are there. No, Shabat tiles means calcium carbonate, which we call limestone. That only Shabat tiles, one time I will take the pieces of it, big pieces I will take, and in second case I will take same Shabat tiles, but I will convert into powder. Means I am changing the size. One I am taking pieces like this, big pieces of Shabat tile I will take in one test tube, and in second test tube I will take the Shabat tile powder. Both chemicals same there, only size different there. Now in both test tube I will add dilute HCl 10 ml. So 10 ml HCl in this, 10 ml HCl in this. Rest process same there. Okay. Only starting we change the here pieces, here powder. So when you add HCl in this Shabat tile actually calcium carbonate there. In this when you add HCl, both will react. It will form CaCl2 plus H2O plus one gas, that is CO2. Now remember, in this CO2 gas which is formed, that CO2 gas you can observe in the test tube in the form of bubbles. So if you see here bubbles are there, these bubbles are nothing but the evolution of the CO2 gas there. Now what children you have to observe here, in case of pieces, these are the pieces there, here powder there. Okay. So if you compare this both, in which test tube you find the more CO2 bubbles, that just you see. So in pieces you see less number of bubbles are there. This last test tube is of powder. Here you will see large number of CO2 bubbles you can see in this. So what it means that more CO2 bubbles means faster is the reaction there. In previous how more hydrogen gas bubbles were there. So faster reaction. Same here. CO2 bubbles are more in case of powder, means faster reaction happening in case of powder. In pieces CO2 bubbles are there but few there, less there, means reaction is slow in case of pieces. Getting? Why like this? Let's understand this. Whenever we talk about any substance in a larger pieces, now suppose this is my reactant Shabat tile pieces there. So Shabat tile pieces which I am having, to that pieces this HCl is attacking. To pieces that HCl is trying to react. So when you are having large piece of that reactant, then contact of acid will be less. If you count here, 1, 2, 3, 4, 5, 6, 7, 8. 8 acids are in contact. But if same shabat type pieces we converted into small powder form, now number of acid will react. Acid can react here also, here also, here also, here also. So when you convert the larger pieces into powder, the surface area for reaction will increase. Always remember this. Surface area for reaction increases, means more chance there that acid will react with this. So to increase the surface area, to make it larger surface area for reaction, we have to convert the pieces into powder. Why like this to do? Because rate of reaction depends on size of the particle of reactant. Smaller the size of particle, faster is the reaction there. Get it? So what to write in the paper? My second factor is the size of particle of the reactant. If smaller the reactant's particle size, faster is the reaction rate. So in case of powder, particle size was smaller. So in case of powder, particle size smaller, faster is the reaction with acid. Getting? So how we understood that faster reaction there? Because more CO2 is formed, more quickly it is formed in case of powder. So from this we understood that whenever we convert the particles of reactant smaller size, the larger surface area available for reaction. That only I just now shown to you. If you break it, everywhere acid can react with this. Here also, here space there, here space there. Everywhere acid molecules can react. So the surface area will be more when the particles are smaller. So what we understood from second factor, smaller the particle size of the reactant, faster is the rate of reaction. Get it? So this is my second factors affecting rate of reaction. Now in this activity we have to take one calcium carbonate powder, and that calcium carbonate powder we have to put in test tube number 1 also, 2 also. Same calcium powder you add in this. Take dilute hydrochloric acid and concentrated hydrochloric acid. Means HCl only acid there, but one weak we have to take, one strong we have to take. So in one test tube I am adding dilute HCl, and in second test tube I am adding concentrated HCl. Are you getting? Dilute means somewhat weak acid we added in this, and here concentrated means somewhat strong acid we have to add. So in both cases same there, powder of calcium carbonate only there. So here we added weak dilute acid and here strong concentrated HCl. So in both cases acid same there, chemical same there. What is difference? Difference is one dilute there, one concentrated there. So when you observe the result, you will find that in which case we added dilute HCl, weak acid, in that bubbles are less. And in which test tube we added strong concentrated acid, in that number of bubbles are more. What it means that if your acid weak there, then reaction is slow, less bubbles will form. When acid strong there, concentrated acid there, then reaction faster there, more bubbles you can see in this case. So from this what we are understanding that means how nature of the reactant was important, like that concentration of the reactant also important. More strong there, more concentrated there, then that case reactions rate will be faster. If your reactant only weak there, less concentrated there, then reactions automatically it will be slow down. So my third factor affecting rate of reaction is concentration of the reactant. Okay, so if the reactant is concentrated there, then the reaction will be faster compared to dilute. Here who was the concentrated? Concentrated HCl. So in this case calcium carbonate it will react faster compared to dilute one. So how we understood that in case of concentrated HCl reaction was faster? Obviously by seeing the CO2 gas. CO2 gas was formed more rapidly, more faster in case of concentrated HCl. Yes or no? Now if you add calcium carbonate in the concentrated acid CaCO3, that powder when you mix with concentrated acid, then it get disappear faster, because concentrated HCl faster reaction will do. Acid added, then calcium powder immediately it will disappear. Dilute added, then it will take time, slow reaction there. So disappearance will be faster in case of concentrated HCl. From this what we are understanding, if the chemical, if the reactant is at higher concentration, then the rate of reactions is always faster. So more the concentrated, more is the faster reaction can occur. Now next factor affecting is very famous, well known there, everyone knowing that if reaction is not happening properly, we have to heat it. If when you heat, the temperature of the reaction increases and reaction will be faster. Getting? So that simple factor we have to understand by using one activity. What I am doing here, I am taking in one test tube calcium carbonate limestone, but I am not heating it. And in second case, same setup there. Here also I am taking limestone, but I am heating it. So when you heat that limestone, CaCO3 limestone there, when you heat it, it will break into CaO plus CO2. That CO2 gas which is formed after breakdown, it will pass through this lime water and colorless lime water will turn to milky white. Getting? So here what is happening? Here reaction taking place, but when you are heating it. But in this case I am not heating, then reaction only not taking place in. So if you want to decompose that calcium carbonate limestone, compulsory we have to heat. Means when you increase the temperature, then only reaction is taking place. So that only you have to write in paper. When there is an increase in temperature, there is an increase in the rate of chemical reaction. More the temperature, faster is the reaction taking place. Getting? So limestone will break down, it will decompose only on heating. If you are not heating it, no CO2, no lime water color change you can see in the first case. But once you heat it, reaction will take place, CO2 gas will form and the lime water will turn to milky white. So what we understood here, higher is the temperature, higher is the rate of chemical reaction. Simple. To understand the last factor, we have to do one more activity. Children, what we are doing in this activity, I am taking potassium chlorate in 2 test tube. So take equal amount of potassium chlorate in 2 test tube. Only one condition we have to change. In first test tube, we have to add one chemical manganese dioxide, MnO2, and in second test tube, not to add that manganese dioxide. Okay. Now both test tube you heat it. So when you heat it, we will get the oxygen gas in this reaction. That oxygen gas we have to release in this gas collecting jar. So here also oxygen gas is collected, here also oxygen gas is collected, but the amount of oxygen gas formed in both the case you have to observe here. In the first test tube we added manganese dioxide. In this case we added manganese dioxide. In the second test tube we not added manganese dioxide. You will find that more bubbles are seen in case of first. Which is the first one? First test tube which there, in which we added the manganese dioxide. So in which case we added manganese dioxide, there more oxygen bubbles are there compared to without manganese dioxide. What it means that manganese dioxide there reaction faster happen, without manganese dioxide reaction slow down. So that manganese dioxide we called as one name, called it as a catalyst. Who is the catalyst? Catalysts are the substances which increases the speed of the reaction. Getting all of you? So my fifth factor is catalyst there. Catalyst what doing? Catalyst increases the rate of chemical reaction. In just now experiment what we seen? Potassium chlorate will decompose slowly when there is no manganese dioxide. But whenever you add the manganese dioxide, decomposition becomes rapidly, more oxygen gas bubbles you can see there. So it means that if manganese dioxide there, reaction faster, without manganese slow there, means catalyst is very important there. Catalyst increases the speed of reaction, rate of reaction. Clear? One last, they can ask to you what is mean by catalyst. So you have to write the substance in whose presence the rate of reaction, speed of the reaction increases without any chemical change in it. Means whenever this reaction will happen, manganese dioxide is used to increase the speed. But when reaction completed, this will not use in the reaction. It will remain like that only. You see now like this. If suppose something teaching going on and teacher is giving to you something work. Chalo, in next 15 minutes you complete your exercise here only, front of me. Now only teacher is standing, but your writing speed will increase. Getting or no? Teacher is not writing. Teacher is just standing in front of you and you are writing. But your speed will be more. If teacher is telling, in next 15 minutes you complete the exercise, my meeting there after 10-15 minutes I will come. Then you will find that your writing speed automatically will be slowed down. So presence of teacher increases your speed. Same there here. Manganese dioxide will increase the speed of reaction. But manganese dioxide is not used in the reaction. That only I am telling, the substance in whose presence rate of chemical reaction increases without causing any chemical change to it. In this, there is no change in chemical. Manganese dioxide will remain as it is. Only because of that, your speed of the reaction will increase. Getting? So this is all about the factors affecting the rate of chemical reaction. Okay. Now let's begin with first question, that is fill in the blanks. First question they asked, to prevent rusting, a layer of dash metal is applied on iron sheet. Now children, this first question is related to prevention of corrosion. One method there to prevent the corrosion, that is called galvanization. In galvanization process, we are giving a layer of zinc on iron sheet. So zinc, when you apply, the process of corrosion will slow down. Okay. So first one answer will be zinc. Second, they asked, if you convert the ferrous sulfate into ferric sulfate, which type of reaction there? For this you have to understand children, ferrous means Fe2 plus and ferric means Fe3 plus. So here what is happening, Fe2 plus is converted into Fe3 plus. How it is possible? When there is a loss of one electron, if this Fe2 plus loses one electron, then it will become Fe3 plus. Means here loss of electron there. And we all are knowing that we are representing oil concept. Oxidation is loss. Whenever there is a loss of electron happening, that is oxidation reaction there. So my answer for this question will be oxidation. Okay. Now let's move to third. When electric current is passed through acidulated water. In water, if you pass electric current, water will break into hydrogen and oxygen. This process we called as a electrolysis. Electrolysis means breakdown of water with the help of electric current. Okay. So third one answer will be electrolysis. Now let's move to the fourth. Addition of aqueous solution of ZnSO4 to aqueous solution of BaCl2. Means I am having ZnSO4, BaCl2, both you have to mix. Then we are getting a white precipitate of barium sulfate. If you see here, white color one powder is settled at the bottom. Whenever in any chemical reaction, there is a formation of precipitate. Such type of reaction will comes under double displacement. So whenever exchange of ion there, exchange of ions of a reactant form a precipitate, then this we called as a double displacement reaction. So my fourth answer will be double displacement. Check the answers. First one is zinc, second one oxidation, third one electrolysis, and fourth one is double displacement reaction. Okay. Now let's move to the next question. Now next question they asked about, identify the given reaction, exothermic there or endothermic. Endothermic means heat is absorbed there, and exothermic means in this reaction heat is given out. If heat is given out, then exo, absorbed, then endothermic. If you not check the previous videos, please go and check. If you are not getting the videos on channel, no, I made a playlist of each topics, chapter wise playlist there. You can go and check out that concept. Now here how to identify sin. Just you have to see that heat or a triangle. Heat is represented by triangle. That heat or triangle, where it is in the equation. If heat word comes after arrow if heat word comes, means it is exothermic there. If heat or triangle word comes on arrow or before the arrow, sometimes we can write the heat before arrow, that's also okay there. If heat word or triangle is coming before or on the arrow, that is endothermic there. If heat word comes after arrow, exothermic there. This much if you remember, you can solve all. Now check the first one, A. Here where the heat word, here came. So after arrow there, after arrow means it is exothermic there. Simple. Check the second. Now here see, triangle came here, triangle on the arrow, then it is endothermic there because we are supplying the heat. Now third C, CaO plus H2O gives CaOH twice plus heat. Heat word where there? After arrow there. So after arrow comes means it is exothermic. Are you getting? Heat word just you check. If after arrow comes then exothermic, on the arrow or before the arrow coming then endothermic. Now you can answer this. CaCO3 when heated. See, triangle means heat came on arrow means it is endothermic there. Simple. So this is your question number 2. Now let's discuss few questions in the answer the following. Okay. Now first question they ask, explain the term reactant and product. Very simple question there. They are asking what is meaning of reactant and product. We all are knowing that whenever chemical reaction taking place, some substance will take part in that. So the substance which is taking part in chemical reaction, that is called as reactant, and the new substance formed after chemical reaction by formation of new bond, that is product there. So that only is simple definition you have tried. The substance taking part in chemical reaction is called reactant, and the substance which is formed after chemical reaction by formation of new bond is called as product. Okay. Now let's give one example. Suppose carbon react with oxygen and forms carbon dioxide. So carbon and oxygens are taking part in chemical reaction, so they are reactant. And CO2, carbon dioxide, is a new substance formed after chemical reaction by formation of new bond. See here, carbon oxygen bond was not there, but in carbon dioxide now bond there between them. So there is a formation of new bond. So simple definitions are there. What is reactant? Reactant means substance taking part in chemical reaction. What is product? A new substance formed after chemical reaction by formation of new bond. That much only you have to write under this question. Okay. Now let's understand the next question. The next question they ask related to oxygen and hydrogen, which type of reaction there, and explain with example. Now children, we are knowing that oxygen hydrogen related we are having two reactions. One is oxidation and second is reduction. We all are knowing that whenever there is a oxidation, two things are possible. When we are talking oxidation, one is reactant should gain the oxygen or it should lose the hydrogen. That is your oxidation there. And when we talk about reduction, what is happening in reduction? There is a gain of hydrogen or loss of oxygen. That's it. So this type of reaction. So that only you have to write here. Oxidation reaction means what? The chemical reaction in which reactant gains oxygen, combine with oxygen means gains oxygen, or there is a loss of hydrogen. So the chemical reaction in which there is a gain of oxygen or loss of hydrogen is called as a oxidation reaction. Take one example. Here see, magnesium one reactant there. Magnesium will gain this oxygen, takes this oxygen and form magnesium oxide. So it is one type of oxidation reaction there. Clear? Now in reduction what is happening? In reduction reaction, reactant should gain hydrogen or it should lose oxygen. Okay? So here see, in reduction reaction, chemical reaction in which reactant combine with hydrogen or loses oxygen. Combine with hydrogen means it gains hydrogen or loses oxygen, is called as reduction reaction. Now here see, carbon when react with hydrogen, carbon reactant there, carbon will combine with this hydrogen to form a methane gas, CH4. Getting? So here reactant is gaining hydrogen. So gain of hydrogen or loss of oxygen is reduction there. This much only you have to explain under this question. Okay? Now let's move to next question. Now to understand the next concept, we will take one example. Now children see here, H2S reacts with SO2, forms sulfur and water. This is a chemical reaction there. Just now we completed concept of oxidation and reduction. By using that concept, can you tell here? Here hydrogen before reaction it was with sulfur. Now after reaction see, hydrogen with oxygen there. Means this hydrogen after reaction taking oxygen, means hydrogen here gains oxygen. Now tell me, in reaction in which oxygen gain happening, that is which type of reaction there? Oxidation. Just now we checked that. Now compare sulfur. Sulfur was with oxygen. After reaction, sulfur alone there, oxygen not there. Means sulfur here loses oxygen. There is a loss of oxygen in this case. So sulfur loses oxygen. Therefore, it is a reduction reaction there. So sulfur dioxide undergoes reduction. H2S undergoes oxidation. So what we are understanding here? It means that in one only chemical reaction, oxidation and reduction both can take place simultaneously. At a time, both reaction possible in single chemical reaction. So, such type of reaction we are giving one special name. They asked a question on this. What is the reaction when oxidation and reduction takes place simultaneously? Just now we checked one example where oxidation reduction both there. See children, if reduction happening in same reaction and oxidation also happening in same, so red from reduction, ox from oxidation, one new word will form redox. So such type of reactions we called as a redox reaction, where one side oxidation happening, other side reduction happening. Getting? So the chemical reaction in which oxidation and reduction both takes place simultaneously, such reactions we called as oxidation. And one example you explain under this question. Okay? Now let's move to next question. Now next question is based on factors affecting rate of chemical reaction. Question read children, how can the rate of chemical reaction, namely decomposition of hydrogen peroxide, can be increased? They are telling if we are having hydrogen peroxide, that is H2O2, and we want to break this hydrogen peroxide into water and oxygen, this is very slow reaction there. And if you want to increase the speed of reaction, what is the option we have? Like this they are asking. So first you write that hydrogen peroxide decomposes into water and oxygen. Write one equation and mention that this reaction is very slow there. And if you want to increase the speed of reaction, one catalyst we have to use here, manganese dioxide. Means on arrow you have to write MnO2. MnO2. So whenever you add manganese dioxide in this reaction, rate of reaction, speed of reaction will increase. Getting? So manganese dioxide will act as a catalyst, and this catalyst role what there? It will increase the reaction rate. So which reaction was slow, to that reaction it will make faster just by adding one chemical, that is manganese dioxide. So this much you mention under this question. Now next one very interesting question they asked about, explain the similarity and differences between NaOH added to water and CaO added to water. Okay, two chemicals we have to add in water, and what is similarity also you have to write and differences also. Let's talk about the similarity. Now children see, NaOH means sodium hydroxide. When you add in water, it will form sodium hydroxide aqueous solution. Means this NaOH will dissolve in this. So when it will dissolve, it will release some heat outside. So just now we discussed, whenever chemical reaction, heat is given out, heat is released there. So it is an exothermic reaction there. So the first one is exothermic there. Now check here. Calcium oxide when added to water, it forms calcium hydroxide. It also releases the heat. Means NaOH and CaO both when added to water, both giving exothermic reaction. In both cases heat is released. So what is my first similarity? Both the processes are exothermic, both releases heat. Now whenever they release the heat, the temperature of that solution will increase. So second point you have to write, the temperature of the solution increases because of that heat. Okay. Now interesting, see here. NaOH there. In 6th standard, 7th standard we discussed that whenever there is a OH minus there, OH minus, it is a basic there. Base is having main component OH minus. And the base which dissolve in water, to to that we called alkali. So alkali means you can consider alkali are nothing but base there. Acids opposite base. That base only we call alkali. So here also alkaline solution will form, basic solution will form, because here also OH there, here also OH there. So both will produce alkaline solution. Alkaline solution means basic solution will form in both the case, because both are having OH. Okay. Now let's talk about what is the differences in this. Now see children, whenever you add the NaOH crystals in the water, that NaOH just dissolve. Means how salt NaCl we add in water and just mix it, it will dissolve. Are you getting? That is not a chemical reaction, just it is a solubilization there. Just salt dissolve in that. Water and NaCl reaction not there. Getting? Suppose that salt solution again you will heat it, then water will evaporate, salt will remain behind. Knowing this process. So like that somewhat here there, that NaOH when you add in water, it is just dissolve. Reaction not happening. No chemical reaction with water. But when you add the CaO in water, it is actually reacting with water. So it is a chemical combination there, chemical reaction happening in this case. So this is first difference there. Here NaOH just dissolve, no chemical reaction. CO when added to water, chemical reaction takes place. Okay. And second C, NaOH is a strong alkali there. Strong alkali means it is a strong base there. Compared to that, CaOH twice is a weak alkali there. Weak alkali means it is a weak base there. Clear? The second is very simple there. Now NaOH when added, it is completely soluble there. When completely soluble, everything dissolves, then only it is called strong. Remember this. The base which dissolves completely, that is strong there. And the base which is dissolved, soluble there, but less, that is weak there. So when I am calling it is a weak base or weak alkali, means it is less soluble there, sparingly soluble there. Sparingly means less soluble there. So that much differences you have to learn regarding this question. Okay. Now next reaction also based on oxidation and reduction. But remember here they not asked to you type of reaction, means whether it is oxidation type of reaction or reduction. That is not question. They give an equation. In that equation you have to identify which substance undergoes oxidation and which substance undergoes reduction. Okay. So let's try the first one. Here children, concept there on loss of electron or gain of electron. Just now I told you, whenever there is a loss of electron, you have to remember the oil. Oxidation is loss and reduction is a gain of electron there. So Fe when react with sulfur, Fe will lose 2 electron. So loss of electron happening from Fe. And whenever loss of electron happening, it is oxidation there. So Fe undergoes oxidation. Why? Because it loses electron. Loss of electron there. That electron who is taking? That electron is taken by sulfur. So sulfur undergoes reduction because it is a gain of electron there. So whoever gains the electron, that will be reduction. Whoever loses electron, that will be oxidation. So Fe oxidation, yes, reduction. That will be your answer. Okay. Now check the second one. Silver oxide after reaction forms silver and oxygen. Now compare children these two. Here before reaction oxygen was there, now after reaction not there. Means what happened here? AgO loses oxygen, loss of oxygen there. And just now we told loss of oxygen is a reduction there. So here Ag2O undergoes reduction. Reduction means loss of oxygen. So as it is losing oxygen, see oxygen here there, but here not there. Loss of oxygen there, so reduction. Okay. Now check the next one. This very simple there. Magnesium single there. After reaction, oxygen there. Means here gain of oxygen happen. Magnesium taking oxygen. So it is a one type of oxidation there. So magnesium undergoes oxidation. Simple. Now here see children, it's interesting there. NiO becomes Ni. Means what happened? Loss of loss of oxygen, sir. Oxygen was there, now not there. So loss of oxygen means what? Reduction. Loss of oxygen is reduction there. So NiO undergoes reduction. So right here NiO. Now hydrogen, see, hydrogen before reaction alone there. After reaction, see, with oxygen there. Means hydrogen here gains oxygen, takes oxygen. So gain of oxidation, oxygen is oxidation. So hydrogen undergoes oxidation, NiO undergoes reduction. Now let's start with first match the pair. BaCl2 plus ZnSO4 double displacement reaction there. So first we'll pair with BaSO4 plus ZnCl2 and it is a double displacement reaction, therefore fourth will come. Second one, see, AgCl decomposition will happen. Ag plus Cl2 decomposition where there? Third option there. So third option will come. Okay. Now let's see the third one. Copper sulfate Fe. Fe more reactive there. Displacement reaction. B option. Displacement first option. Now last one, see, fourth one. Water CO2 combination reaction there. H2CO3 will form. Combination is given at second position. So this is all about your first match the pair. Very simple there. In 2 minutes you can finish it. Next part, which is very important there, that is related to give reason. Now student, what just now I am informed to you, these give reasons are most commonly they are asking in board examination. So carefully you have to understand the give reasons of this chapter. In first give reasons we are talking about heating of limestone. Now when limestone you are heating, two things will form. One, CO2 gas will form and one product will form CaO, that is calcium oxide or quicklime. So calcium carbonate means CaCO3, when heated it will form CaO, that is calcium oxide, and carbon dioxide gas. But carbon dioxide gas formed or not, how I will identify? Because carbon dioxide gas is colorless, tasteless, odorless there. So that CO2 gas formed or not, to find out that we are having one test. Here what we are doing, whenever such CO2 gas is formed, that we have to pass through one gas delivery tube and that CO2 will enter in lime water. Lime water is CaOH twice there. So CO2 gas when enters in lime water, it will perform one reaction. So what is that reaction? Lime water and CO2 when react, it will form calcium carbonate insoluble precipitate. So this calcium carbonate which is formed, it is insoluble solid there. It will not dissolve. Because of this calcium carbonate, the colorless lime water will change into milky white color. If you see here, milky white color came to lime water because of which chemical? Insoluble calcium carbonate. So in paper they are asking to you, when CO2 gas is passed through lime water color changes to milky white, give reason. Getting? What is the main reason there? That CO2 will react with that lime water and form one chemical, calcium carbonate, which is insoluble there. Very important word. It is an insoluble calcium carbonate there. Because of formation of insoluble calcium carbonate, the colorless lime water will turn into milky white. That much only you have to write in case of this question. Now let's move to the next question. Now next question, it is related to rancidity. We all are knowing that any food items, food stuff prepared in oil or ghee, if you keep for many days, for long duration, if you are doing storage of that, its taste and smell changes and that will become rancid. Rancidity means the taste and the smell of the oily substances changes because of reaction. What is that reaction? It is called air oxidation. So those atoms made in an edible oil, if you keep for longer time, it will undergoes air oxidation, its smell and taste changes. This concept we called as a rancidity. Means that food stuff becomes rancid. Okay. Now how to avoid this rancidity? We are having many options. We are talking mainly about two options. One, those food stuff which are prepared in oil or ghee, that food stuff, one extra substance you add in that, it is called antioxidant. See, rancidity why happening? Because of oxidation, right? When that foodstuff get oxidized, its taste and smell changes. Now we don't want that oxidation, so we are having some chemical called as antioxidant. If that antioxidant you are adding, your oxidation get prevented. Getting? So my first option will be, by using antioxidant we can prevent the rancidity of the foodstuff. Now second option we are having, that whenever you are making the foodstuff in oil or ghee, immediately make that foodstuff airtight. So like this airtight containers are coming. In such airtight container, if we are keeping that foodstuff, that bad smell and taste will not change. So in simple language, rancidity can be slowed down if you keep in this airtight container. So that only in due reason they are asking, it is recommended to use airtight container for storing oil for long time. Clear? So what is the main point here to remember, that whenever the foodstuff prepared in oil or ghee, if it is kept for many days, its taste and smell will change. That is called rancidity, right? Second, this rancidity can be prevented by adding antioxidant, or this can be slowed down by using airtight container. Clear? That much if you write, it is enough there. Now next give reason is related to factors affecting rate of chemical reaction. Very simple concept there. Here we have to compare the Shabat tile powder and pieces, who will react faster. Means they are asking to you, if I am having a Shabat tile pieces and powder both added to HCl, who will disappear? Who will disappear rapidly means what? Who will do faster reaction? That only they are asking. See here. So they are taking first one pieces and one powder, both added to HCl. Okay. Now, when we talk about such type of question, children, first thing you have to understand, they are talking about size of particle of the reactant. Always remember that if particle size of the reactant is smaller there, smaller particle is having more area, larger area for reaction. So particle small there then means surface area for reaction increases, and because of that more reaction will happen. Rate of reaction, speed of reaction will be more in case of smaller particles. So that only we have to mention in give reason, that rate of chemical reaction depends on particle size of the reactant. Smaller the particle, larger the area available for reaction, faster is the reaction. Check here. The rate of chemical reaction depends on size of particle of the reactant. Easy. Smaller the particle, more is the surface area for reaction, faster will be the reaction. Get it? So because of that, when you add in HCl, these both pieces and powder, which reaction will be faster? Obviously, in case of powder, the fast CO2 formation there, effervescence of CO2 means bubbles of CO2 will be faster, means here reaction faster happen, it rapidly dissolves. Here also you will find the bubbles but less there. So slow effervescence of CO2 means CO2 bubbles are forming but in less number. Why? Because here reaction slow there, because particle size is bigger. Here reaction fast there, because particle size is smaller. That's it. That is the main concept you have to explain in case of this give reason. Okay. So next give reason is related to how to prepare the dilute sulfuric acid from concentrated. Very simple give reason there, and very important for your lifetime knowledge, that how to make the acid dilute. Now see children here. Whenever I am taking the concentrated sulfuric acid and I am mixing water with that, between these two chemical, highly exothermic reaction will take place. Means when acid and water will combine, it will give lot of heat outside. Highly exothermic there. So because of that exothermic reaction, sometimes accident possible. So we have to mix the water and acid very carefully by one specific method. What is that method? See, first we have to take the water in a large amount in the vessel, and slowly in a small quantity we have to add the acid into it with a constant stirring. Here if you see one rod there, with that rod you have to mix that, stirring we have to do. So small amount of acid, concentrated acid is added to water with a constant stirring, then that heat generation will be less, accident can be prevented. Suppose little bit more heat is, you are feeling that heat more happening, then you can cover that vessel in a surrounding ice caps also. Ice you can keep so that the heat generated will be cooled down and accident can be prevented. Get it? Suppose by mistake you don't know this method and you are trying to add the water into acid. You are taking the concentrated acid in the vessel, and in that vessel if you are adding water, then when water enters in that acid, exothermic reaction will take place and that added water will evaporate. Sudden evaporation of that water also splashes the acid outside, and when acid will splash out, it can cause accident to you. Maybe permanent damage to your face or body parts possible. So carefully you have to do this dilution. Always remember we have to add the acid to water, not water to acid. Okay. So related to that, give reason there. What is given in the answer? See here once. First point you have to write that preparation of dilute sulfuric acid is highly exothermic reaction there. Means large amount of heat is released in this. Okay. So what we are doing here? Here slowly we are adding the concentrated sulfuric acid to water with a constant stirring so that heat will generate but very small amount. Okay. Sometimes what we can do, we can surround it by ice so that overheating will be avoided. Now if you do this one, if water is added to the concentrated sulfuric acid, then problem will create, because that time large amount of heat will be released and because of that water will evaporate and which will splashing out that all acid outside, which can cause dangerous accident to you. Get it? So always what to remember, add acid to water, never add water to acid. Okay. Now let's move to the next question. So let's understand the last question, that is related to rusting of iron. This question so many times came in board examination. Let's understand this in proper way. Here children, always remember that whenever the iron will rust, it will get a reddish brown color. This reddish brown color rust which is formed on iron is always because of oxygen gas. So you can say that rusting is actually oxidation process there. No doubt in that many electrochemical reactions are happening. Electrochemical reactions are there, but basically it is a oxidation there. So we can say rusting is an process of oxidation there which involve many electrochemical reactions. Not only this, whenever the iron will rust, some part of iron will act as a cathode and some part will act as an anode. So we can say that different parts of the iron, different regions of iron surface can act as an anode and cathode. Now let's understand what is happening at anode. See children, we are having Fe, iron. This Fe will lose 2 electron. It will lose 2 electron and it will form Fe2+. Now we all are knowing the concept of oil, OIL. What is oil? Oil is a oxidation, is a loss of electron. So electron loss happening here means it is a oxidation there. So we say here Fe undergoes oxidation. Fe oxidized. So at anode iron get oxidized. Everyone understanding why it is called oxidized? Because loss of electron happening. And what will form? Ferrous ion means Fe2+ ion will form. Where it is happening? It is happening at anode. Now when we talk about cathode, children, at cathode oxygen undergoes reduction process. Means if you want to write in a simple way cathode reaction, I will give one method to you. Don't write from the reactant side. No doubt, ideally we have to write the reactant and then product. But for easy understanding, to remember that, you write first water molecule 2 and come reverse. Reverse you come. Now see, how many hydrogens are there here? 4. So 4H plus you write. Oxygen how many there? O2 there. 2 oxygens are there. So you write O2, and this electron which is lost, it will come to oxygen. So 4 plus there means obviously 4E minus will come. So O2 plus 4H plus 4E minus plus 2H2O. This is your cathode reaction there. So how I wrote? I wrote first product and then I came this side. That will be easy for learning purpose. Getting? Here oxygen is taking electron. Gain of electron happening. It will gain the electron. Then I gave one word to you, RIG, R-I-G. Reduction is a gain. So electron gain means O2 undergoes reduction. It is reduced. So you have to remember at cathode what is happening. At cathode oxygen get reduced. Why textbook telling word reduced? Because oxygen is taking electron. Gain of electron means reduction. Okay. So at the cathode oxygen get reduced. In this process hydrogen ions will form water. Hydrogen ions will form water. That is your cathode reaction there. Now when this process is happening at anode and cathode, this Fe2 plus will migrate to this side. It will migrate and it will convert into Fe3 plus. Are you getting what I am talking? Already I was having the Fe2 plus. When that Fe2 plus will move, it will again lose one more electron. It will lose one more electron. So this Fe2 plus will become Fe3 plus. Again loss of electron there, means again oxidation happening. So Fe2 plus ions, when it is reacting with water, it further oxidized. Why oxidized? Because one more electron it is lost and it will become Fe3 plus. Okay. Now this Fe3 plus what doing? Fe3 plus will react with that water. That is your final equation there. And to write final equation also I will give one method how to do it. We all are knowing that Fe3 plus will react with water and what is forming? Rust is forming. So already we are knowing the rust formula. If you don't know, you learn this because separate question will come on that. What is the formula of rust? What is the definition of rust? One marks questions are there this. So rust formula you should know. What is that formula? Fe2O3 dot H2O. Here in this reaction you have to write dot H2O. When they will ask the formula, that time you have to write Fe2O3 dot XH2O. That is rust formula there. Okay. So product already I am knowing. I am going to make the Fe2O3 dot H2O. This is my final there. Okay. Now according to that this side balance. You don't learn this. Smart work you do. Now what will come, see here. If I am having already product, I am knowing what is going to form. How many Fe I used here? Fe2. So you write 2 here. Second, oxygen check. 3 here, 3 here and 1 here. Total 4 are there. 4. So 1 here, 4 you have to write here. 4 oxygen here, here 4 oxygen. Perfect. Fe2, oxygen 4, 3 plus 1, 4. Now hydrogen check. 4 2s are 8. How many I used here? Only 2. 4 2s are 8 hydrogen there. I used only 2. Means 6 are remaining. So that 6H plus used to, your final equation will be ready. Getting? So that only you have to write here. Fe ions which is there, it will form a reddish brown hydrated ferric oxide. This is your reddish brown color also. You can see here reddish brown hydrated. Why? Hydrated means in this water there, therefore hydrated. So Fe3 plus will form a reddish brown hydrated ferric oxide that we call rust, that is get deposited on iron surface like this. Okay. So this reddish brown hydrated ferric oxide we called as rust and its formula Fe2O3 dot XH2O there. Okay. Now this whole process what is happening, see, before we were having the very neat and clean metal was there. After few days it will undergo corrosion. So corrosion what there? Corrosion is a damage of metal surface there. Metals are getting damaged due to the oxidation, due to air and moisture. Or you can say like this, slow process of decomposition, destruction of metal due to atmospheric effect. So that we have to write that gradual damage. Gradual means slowly damage there. So gradual damage of metal due to oxidation by air as well as moisture. This is called as corrosion, and rusting is one type of corrosion there. That much only you have to mention under this title of rusting process in case of iron. This is all about your chapter number 3. If you like our videos, please subscribe the channel and share the link with your friends. Thank you.